All right, welcome back to pre-calculus. We have another partial fractions problem to deal with here. So we have a partial fraction that looks like this numerator, and we have a denominator, and we have to go ahead and figure out what's going on here. So let's figure out if we could factor the denominator here. We've got an x to the fourth plus 8x squared plus 5 or plus 15. To me, that looks like an x squared, looks like plus 3 times an x squared plus 5 5x squared plus 3x squared. That should be my 8. And then we are all set for what's going on here. So we have 7x cubed minus 8x squared plus 27x minus 34. And let's go ahead and go to it. So I've got two irreducible quadratics sitting here, okay? So that's what we have. So we're going to set this thing up to be equal to, and I have a 7x cubed minus 8x squared. What is that? Plus 27x minus 34 over my denominator. And we're going to say that that's going to be an ax plus b over x squared plus 3. And we have a cx plus d over an x squared plus 5. All right. So first step is we are going to go ahead and multiply by all the denominators x squared plus 3 times x squared plus 5 in order to clear my fractions. So let's go ahead and I'm going to write the left side on the right, or the right side on the left here. So I have an ax plus b, parentheses, bx squared plus 3's will cancel. So I'm going to end up with an x squared plus 5. Okay, we have a plus cx plus d. And we have, it looks like an x squared plus 3 here, and the x squared plus 5 cancel, equals, and then we have a 7x cubed, is that a minus? Minus an 8x squared plus 27x minus a 34. And let's see where this goes. So let's untangle the left-hand side. So I have an ax cubed, right, plus a bx squared plus a 5ax plus a 5b. And we have a cx3 plus a dx squared plus a 3cx plus a 3d equals, and this is my right-hand side. Let's go ahead and agree it as right-hand side. Okay. Now, what I'm going to do is do something called equate coefficient. So what I'm going to do is I'm going to pull out all of my x cubes, and we're going to set them equal to my x cubed over here. So I have my x cubes. So I have an a, it looks like plus a c is equal to 7. All right. Now let's go ahead and pull out my x squared. So I have a bx squared. So we have x squared here. So I have a b, I'm going through, I have a d, and then that's it for that. And we have an 8, we have a negative 8 on the other side here. All right. And then it's for my linear term, my x. Let's see, we have a 5a. Okay. I have a plus 3c. Okay. And then on my right-hand side, I've got a 27. There's no dx's or anything like that. There's no bx's. So just ax. It's the only one I have. And a cx, and it's the only one I have. For my constant, let's see here. We have a 5b. Okay, here's my constant. 5b plus 3d is equal to negative 34. Okay. Now, I'm going to make an observation here is that A and C in both of my equations have nothing to do with a B and a D. Okay. So A and C are completely independent of B and D. So while I could work this as a four equations and four unknowns, what I'm going to do is I'm going to say, hey, there's two equations here. And we have another two equations that don't depend on the first two equations at all. And what I really have is two equations, two unknowns, but I have two sets of two equations, two unknowns. So what we're going to say is, okay, I've got A plus C is equal to 7. So we can go ahead and do that. I've also got 5a plus 3c is equal to 27. I also have one of my other two equations. We have, give me a moment. I'm going to stop us right here. Pause. Okay, there we go. So I turned on the fan, so hopefully that's not going to interfere with the auto quality too much, but here we go. So we have two equations. We have a plus c is equal to 7, 5a plus 3c is equal to 27. We also have that b plus d is equal to -8, and we have that 5b plus 3d is equal to -34. Okay, and it's just pulling the two equations off from my big system, recognizing that A and C have nothing to do with B and D. So I could put this, like kind of pull this together and saying, okay, we've really got two sets, the two equations, two unknowns, rather than one giant set of four equations, four unknowns. Okay, so let's go ahead and do this. So it's your choice. I'm going to go ahead and eliminate variable c here by multiplying the top by -3. Let's go ahead and just see what that looks like. So I've got -3a minus 3c is equal to -21. I've got a 5a plus 3c is equal to 27. We're just going to add these two equations together, and we get 5 minus 3, which is 2a. 3 minus 3 for the c's is 0. That's kind of what I wanted. And we have 27 minus 21, and I end up with a 6. So we have 2a is equal to 6. A is equal to 3. Okay. And since I know that a is equal to 3, a plus 3 plus c is equal to 7. 3 plus c is equal to 7. C is equal to 4. Okay. So that's two of my letters that I've sorted out there. All right. Now for the next one, again, I think what I'm going to do is eliminate variable d just because they're smaller numbers and multiply this piece by -3. So I have -3b minus 3d is equal to positive 24, negative times negative rather. And then we have a 5b plus 3d is equal to -34. All right, excuse me. So let's see here. If I add these together, I've got -2b, 5 minus 3 is equal to 24 minus 34 should be -10. And then we'll go ahead and divide both sides by -2. We have b is equal to 5. Okay. And then we have to plug that into our equation and see if we can get anything else to come out of this. We have b plus d is equal to -8. b plus d is equal to -8. All right. One of my b's, I know b is equal to 5, so we're going to say 5 plus d is equal to -8. Subtract 5 from both sides, and we get d is equal to -13. Okay, great. So my partial fractions here are going to be, let's go all the way back up here. How did I set this up? I have ax plus b. So we have 3, and what was my b? B was equal to 5, so we have 3x plus 5 divided by, and I think that was x squared plus 3. And then we have, so that's ax plus b. And then we have a cx plus d. So let's go ahead and put those together. So my c was 4, so I have 4x minus 13 over x squared plus 5. And that was my other term, and that is my partial fraction decomposition for that problem. All right. So that's how we'll go ahead and sort that through and say, all right, that was a bit of a long one, but if you can make little abbreviation, if you make little shortcuts like that, instead of solving a 4x4, you can solve two 2x2s. It tends to go a lot faster. So try to be on the lookout for those things, and you don't have to do a whole big problem. All right. Thank you very much for watching the video, and we will see you in the next one. All right. Take care.